Hello, I will now introduce you to the concept of similar triangles. Let me write that down. Similar triangles. So in everyday life, what does similar mean? Well, triangles, no, triangles. Anyway, so what does similar mean in everyday life? It means if two things are similar, they're kind of the same, but they're not the same thing, or they're not identical, right? And that's the same thing for triangles. So similar triangles are two triangles that have all the same angles. All the same angles. For example, let me draw two similar triangles. So I'll try to make them look kind of the same because they're supposed to look kind of the same, but just maybe be different sizes. So that's one. And then I'll draw another one that's right here. I'm going to draw a little smaller to show you that they're not necessarily the same size. They just are the same shape, essentially. One way I like to think about similar triangles are they're just triangles that could be kind of scaled up or down in size, or flipped around, or rotated, but they all have the same angle, so they're essentially the same shape. For example, in these two triangles, if I were to tell you that this angle, and this is how they do it in class, this angle, whoops, I'm still using the line tool. If I were to tell you this angle is equal to this angle, and I told you that this angle up here is equal to this angle, well, a couple of things. You already know that this angle is going to be equal to this angle. And why is that? Well, because if two angles are the same, then the third has to be the same, right? Because all three angles add up to 180. For example, if this is x, this is y, this one has to be 180 minus x minus y, right? That's probably too small for you to see. But that's the same thing here. If this is x and this is y, then this angle right here is going to be 180 minus x minus y, right? So if we know that two angles are the same in two triangles, then we know that the third one's also going to be the same. So we could also say this angle is identical to this angle. And if all the angles are the same, then we know that we are dealing with similar triangles. And so what useful things can we now do once we know that a triangle is similar? Well, we can use that information to kind of figure out some of the sides. So even though they don't have the same sides, the ratio of corresponding side lengths is the same. I know I've just confused you. Let me give you an example. For example, let's say that this side is, I'm going to draw it in the correspond. Let's see, this side is 5. Let's say that this side is, I don't know, I'm just going to make up some numbers, 6. And let's say that this side is 7, right? And let's say we know that, I don't know. Let's say we know that this side here is 2, right? So we know the ratio of corresponding sides is the same. So if we look at these two triangles, they're of completely different sizes, but they have corresponding sides. For example, this side corresponds to this side. How do we know that? Well, in this case, they just happen to have the same orientation, but we know that because the sides are opposite the same angle, right? This is opposite angle y, and then this side is opposite angle y again. This whole triangle might be too small for you to see, but hopefully you're getting what I'm saying, right? So these are corresponding sides. Similarly, this side, this blue side, and this blue side are corresponding sides. Why? Not because they're kind of on the top left, because we could have rotated this and flipped it and whatever else. It's because it's opposite the same angle. It's opposite the same angle. That's the way I always think about triangles. It's a good way to think about it, especially when you start doing trigonometry. So what does that help us? Well, the ratio between corresponding sides is always the same. So let's say we wanted to figure out how long this side of this small triangle is. Well, there's a bunch of ways we could do it. We could say that the ratio of this side to this side, so x to 7 is going to be equal to the ratio of this side to this side, is equal to the ratio of 2 to 5. And then we can solve it. And the only reason why we can do this, you can't do this with just random triangles, you can only do this with similar triangles. So we could then solve for x, multiply both sides by 7, and you get x is equal to 14 over 5. So it's a little bit less than 3. So 14 over 5. So 2.8 or something like that. That equals x. And we can do the same thing to figure out this yellow side. So if you know two triangles are similar, you know all the sides of one of the triangles, you know one of the sides of the other triangle, you can figure out all the sides. I think I just confused you with that comment. But let's keep. So this side. So let's call this y. So we could do it the same way. We could say y over 6 is equal to 2 over 5, right? Make sure if you're doing, one triangle is going to be the denominator here, then that same triangle has to be the denominator on if one triangle is the numerator on the left-hand side of the equal sign, right? So the smaller one's the numerator, then it's also going to be the numerator on the right-hand side of the equal sign, right? And I just want to make sure you're consistent that way. If you flip it, then you're going to mess everything up. And we could just solve for. So y is equal to 12 over 5. So y is equal to 12 over 5. So let's use this information about similar triangles just to do some problems. Image clear, image invert colors. Okay. So let's say I had. So let's use some of the geometry we've already learned. I have two parallel lines. And then I have a line like that. And then I have a line like this. And what did I say? I said that the lines are parallel. So this line is parallel to this line. And I want to know if this side is length 5. If this side is length 5, what is, well, let's say this length is length 5. Let's say that this length is, let me draw another color. This length is, I don't know, 8. I need to know what this side is. Actually, no, let me give you one more side just to make sure you know all of one triangle. Let's say that this side is 6. Right? And what I want to do is I want to figure out what this side is right here. What this side is, this purple side. So how do we do this? So before we start using any of that ratio stuff, we have to prove to ourselves, and prove in general, that these are similar triangles. And so how can we do that? Let's see if we can figure out which angles are equal to other angles. So we have this angle here. Is this angle equal to any of these three angles in this triangle? Well, yeah, sure. It's opposite this angle right here. So this is going to be equal to this angle right here. Right? And so we know that its opposite side is its corresponding side. So we know that it corresponds to, we don't know its length, but we know it corresponds to this 8 length, right? Oh, no, let's say I forgot to give you some information. I forgot to tell you that this side is, let me put it in neutral color. Let's say that this side is 4, right? Okay, let's go back to the problem. So we just figured out these two angles are the same, and that this is that angle's corresponding side. Can we figure out any other angles are the same? Let's see. Let's say we know what this angle is. Let's say we know this angle. I'm going to do like kind of a double angle measure here. So what angle in this triangle, does any angle here equal that angle? Sure. We know that these are parallel lines, so we can use alternate interior angles to figure out which of these angles equals that one. But I just saw the time and I realized I'm running out of time, so I will continue this in the next video.